Hi there, folks. Mr. Pygott here. AB 2007, question number 3. And part A says explain why there must be a value for R for 1 to 3 such that h of r equals -5. So part A. Okay. Well, the fact that they are giving me some interval 1 to 3, that makes me think. This is either mean value theorem or intermediate value theorem. And if you read the question, they say f and g are differentiable. And if f and g are differentiable, that means h also has to be differentiable. So if they want me to prove something on the interval 1 to 3 for h, I want to find out what is h of 1 and what is h of 3. Hopefully it will help me, but there's only one way to find out. So let's go ahead and find h of 1. Alright, h of 1 is f of g of 1 minus 6. And now let's look this up. What is g of 1? G of 1 is 2. And f of 2? F of 2 is 9. And if we do this, we get h of 1 is 3. 9 minus 6 is 3. Okay, that's my first piece of information. Second piece of information. You're heading out?
No, they're coming over briefly.
Okay, that's fine.
They'll be here when you're done with the video. Hey!
Perfect. Alright. The next one is h of 3.
I gotta walk back by, sorry.
Yeah, no problem. So we're going to plug a 3 here. So h of g of 3 minus 6. We're all good. So if we look up g of 3, g of 3 is 4. F of 4, if we look up f of 4, that's -1. And we get -7. Do I need to know something?
Yeah.
What's up?
Sure you want all this on video. His mom's not coming with him, his dad's coming with him.
Perfect. Well,
fine,
we're
you're
here. Absolutely. That's fine. And that's how we responsibly adult. Good. All right. I'll see you guys. Have fun. We're good.
See you here.
Yeah. No problem.
Okay.
All right.
Come out and say hi.
Yeah, sure. Yes. Let me finish this video first. So let's go ahead and look at these two. H of 1 is 3. H of 3 is -7. Now, h is differentiable. If h is differentiable, that means that it's also continuous. It's implied. So what we're going to say here is because h is continuous by the IVT. Now, what in the world is the IVT going to guarantee us? I don't know what the graph of h looks like, but I do know at 1, oops, I didn't give myself a lot of space, that's fine. At 1, the graph is way up here at 3, and then by the time we're at 3, it's way down here at -7. Well, guess what? If I want to get from a height of 1 to a height of -7, the intermediate value theorem guarantees I'm going to cross every single height in between. And what height happens to live in between those two? What we're looking for, -5. So we don't know exactly when, but we do know that by the IVT, basically, -5 is between 3 and -7, right? And we already said that that's this and this. So, therefore, h of r must equal -5 at least once. We don't need that must. H of r is equal to -5 at least once on the interval. Okay, so that's the first one. And the second one, instead of talking about h of r, it's talking about h prime c. So, part B. Whoops. So, part B. So, the fact that they're saying, will h prime c equal 5? that is reminding me of the MVT. H prime C would be H of B minus H of A over B minus A. And we actually can go, I shouldn't have erased that. We found out H of 1 was 3 and H of 3 was negative 7. That's what I need for the mean value theorem. So, because H of x is differentiable, okay, got to be differentiable or you can't use the mean value theorem. And if you write differentiable, it implies continuity, okay? H prime C would have to equal, and now H of B minus H of A over B minus A. This right here, this is your y's on top, your x's on, your y's and your x's. So let's subtract our y's on top. Negative 7 minus 3, and then 3 minus 1. So that's negative 10 over 2, which means it has to equal negative 5.
Wow, great job.
Probably should write by the MVT. Okay, that's part B. All right, now we're going to go look at part C next. All right. Part C. Let W equal all right, and this question they want to know what is W prime 3. But guess what? Before you find W prime 3, you should find W prime x. All right, so how do I get from W to W prime? I take the derivative. And if I take the derivative over here, I've got to take the derivative over here. And over here, the derivative destroys the antiderivative. G of x jumps in times chain. So the G of x jumps in right there. So now it says f of G of x and then times chain. And when I say times chain is always the derivative of what's over here. So the derivative of G of x is G prime x. And now I can answer what is W prime 3. So W prime 3 is f of G of 3 times G prime 3. If I look up G of 3 is 4. And now if I look up both of these, f of 4 is negative 1. G prime 3 is 2. And that gives me an answer of negative 2. Let's make sure that's the correct answer. Yes. Yes, it is. All right, so that's part C, negative 2. All right, last part. All right, so now we need part D. Let's see what part D has. G negative 1 is the inverse function of G. Write the equation for the tangent line of G prime x at x equals 2. Okay, so couple things. Inverse function. So here we have G of x, and over here we have its inverse function. So if G of x has the ordered pair 2 comma something, G prime x has the ordered pair something comma 2 because the x's and the y's get switched. So if we're looking at G of x has the ordered pair of 2 comma 3, which means the inverse function has the ordered pair of 3 comma 2. That's the first thing. The second thing is the slopes. Well, what is G prime 2? If I look at G prime 2, G prime 2 is 1. And I know this is going to sound weird, but remember with inverse functions. Oh. Wow, I made a big mistake. Let me go back. Rewind! Rewind! Okay. I did not see that they wanted us when x is 2, and they defined x as being here. So they're saying when this one has the x being 2. I'm so sorry. I did not pay close enough attention. So they said the x is 2, so the 2 has to go here. Now, if the inverse function has an x being 2, well, that means over here the y has to be 2. Okay, so let's look at g of x where the y is 2. When the y is 2, the x is 1. Okay, sorry about that. I didn't notice the x. They said g negative 1x, and they said x is 2, meaning a 2 had to go here in this one. Okay, and now let's look at the slope. Well, the slope here, I would use 1. G prime 1, the slope at 1, if we look this up, is 5. And remember, inverse functions, their slopes are reciprocals. If we went way back to the formula I gave you before, g prime y is 1 over f prime x when x and y are in f of x. Okay? Well, here we want, they're still inverse functions. So this one's the inverse function slope. So I want to know what's the slope. I'm having trouble writing this. I think you put a negative 1 here in parentheses and then a prime of y. But anyways, the idea is that if you know this one's slope, then the inverse function will have a slope that's the reciprocal. So g prime 2 here is 1/5. 5, 1/5. The reciprocals, you take the 5, you put it there. Okay, so this is important because now we can take the point and slope and write the equation of the tangent line in point slope form. So it's y minus y1 equals m times x minus x1. And that's a 1. That's an ugly 1. Let me make sure that looks good. We did it. Congratulations. That's not a very fun question, but we did it. All right, thank you, and goodbye.